Hello, my name's Keith. Welcome to another PolyWorks video. Today we're joined by a special guest, Paul.
Hi, I'm Paul. I'm the Director of Manchester Metrology Limited.
So what are you here to show us today?
We are official resellers for the PMT arm and CMM. So yeah, we've come to show you the PMT arm today with the PolyWorks software and the scanner. So this is the PMT arm. This is a 3.5 metre arm, the 7-axis, which includes the scanner. They also do the 6-axis arm. So basically you can have a 4 foot to 4.5 metres. The starting price for just the 6-axis arm is 16,500 up to the top spec 4.5 metre P with the adapter for the scanner to about 35,000 for the complete unit. The scanners range from 11,000 to 14,000 depending on whether you want SD or HD. So basically this one has got 7 rotary encoders. There's no end stops on the encoders, it's fully rotational. So basically fully counterbalanced. So you've got the full counterbalance so it doesn't swing into the table. So it's quite a nice arm to use. It's basically a 3.5 metre arm which mounts on a 3.5 inch Whitworth ring, which is industrial standard for arms, tripod, vacuum mounts, mag mounts, everything. So there's a quick release handle, but also you can use the spanner if you want to. So you put the arm on and just tighten it up. Okay, so on this one, it's got dual battery. So the batteries are hot swappable. So you can just take a battery out, charge this one. So you will get 8 hours use out of an arm with dual battery. Also, if the battery is in, it will charge on full power. We also have Bluetooth and wireless connectivity as well. So if you're in a position where you can't use the cables, then you can use the Bluetooth and wireless. Also has a handle for ease of use. So it's quite handy to get the arm in there. So once you've done that, you can just set up, tighten the arm up on the mag mount, and that's basically the arm. The models of the arm they do is the P, which is the high accuracy, the M and the E. So this one is a 3.5 metre, which is 57 microns, full accuracy over its 3.5 metres, and it is single point to 43 microns. So what that means is if you were going to the same point, you will get repeatability to within 43. If you were measured to point to there and a point to there, it would be within 57 microns over 3.5 metres. The scanner is down to 25 microns, so obviously if you add the scanner, you're going to add another 25 microns onto that specification.
So let's see this arm in action. What we'll do is we'll connect it to PolyWorks. We'll import a CAD model. We'll do create some features. We'll then scan it, best fit, and extract those results from our part. And Paul can demonstrate the scanning for us. So if I jump into PolyWorks, what we can do is we'll start by importing our CAD model. And with our CAD, we can then obviously start by creating our features. So we've just got to create a handful of features, some circles, planes. And while I'm here, I can even do some additional dimensional information as well, maybe some distances between the holes. And that's all, if that's all I need, obviously we can start scanning. So jump into our device ribbon, we can make sure that we are connecting to our PMT devices. If I jump into our scanning tool, we can then start scan, and then if Paul can do the honours.
So basically we can remove the arm from its stop, make sure the counterbalance is there, and then just press the green button to start the scan. And then like a paintbrush, we could just go through and scan the areas that we...
So if customers were to purchase an arm, what do they typically get with a kit?
So the arm comes with a 3mm, 6mm probe. You can have the standard probes, or you can go to the kinetic probes, which means that in situ you can change them, the hot swappable. So because they're already calibrated, it already knows the calibration. So what that will do, it means in sort of measurement mode, you can just swap and it knows where it is. So usually you would have to recalibrate every probe every time you take it off. Right. But with the kinetic mount, that means the scanner is already calibrated and the probes are already calibrated.
Cool. And if customers were to purchase an arm, what's the kind of, how long do they typically wait for a device to arrive?
We usually say about 6 weeks for the device to arrive into the UK.
And in terms of annual servicing and maintenance?
So that is all done in the UK at our Manchester facility. So we have a full calibration lab, so we can do all repairs, all error mapping and all calibrations. And our sister company, Apex Metrology, can do UCAS calibration, so they're fully UCAS calibrated.
So what we'll do is we'll let that to finalize. So that is scanning straight into PolyWorks. Like many other scanning devices, it's done a real-time quality mesh. So we have a polygon model now. And obviously with that, we can obviously now align this to the CAD model by performing just a basic best fit alignment. So we'll perform a best fit data to reference. We'll use the automatic option, see if that works. We'll try that again. Try an automatic option first. If that doesn't work, then obviously we can go back and try a point pair alignment. Which in this case it didn't. In this case, the reason being is we have actually more scan that the actual CAD has. We've got an extra part on this, the physical part that doesn't exist on the actual CAD. So in that case, what we'll do is undo that, and we can always try that again using the best fit, but this time using a point pair alignment instead. So if I use a point pair alignment, I can then pick at least 3 pairs of points, if not more, and then we can align the two together. So if I pick some common points that I know can quite easily repeat on the two models. Again, minimum 3, more if you really wanted to, but there's not necessarily any more benefit by picking more points. So 3 or 4 is plenty. I can then either right click or click on the tick box, say align, and you should then snap the two and perform a best fit. Now that we're aligned using a best fit, we can go ahead and extract our features. So you just right click and say extract measured. We do have some issues where we maybe don't have enough detail on the inside of the holes. So what we can do is adjust the extraction parameters to make sure we do a better job of extracting from those holes. So if I select those circle features, we can actually adjust the extraction parameters. So if I right click on those, go to properties, we can jump into the measurement tab and we can set the method, a sub-method for extraction to trimmed. This tells PolyWorks that we aren't working with data inside the holes, we only have data on top. Main reason being is because we're dealing with sheet metal parts where there's a very thin thickness to it, so there's not much detail on the inside. So we'll try doing a trimmed sub-method. Something else might be worth doing here in this case is maybe performing a min fit of these circles to fit a circle to the most inner points only, rather than performing a best fit. If I apply that, we should get better results. You see they're now measuring. And obviously what we can do is, now that we have that information, we can finalize the alignment rather than just sticking with the standard best fit. We'll perform more feature-based alignment. So what I could do is potentially align using a plane, 2 circles. So we perform a plane axis center point alignment. We can align using maybe plane 1 measured to plane 1 nominal, circle 1 measured to circle 1 nominal, and then circle 2 measured to circle 2 nominal. Align, and you can see that's shifted across, and we now have a new alignment, and that gives us our results. So they have nominal measured information now. They have our standard tolerance information. You can see our pass and fail. And even for our dimensional information as well, that will have our distances and the 2 axes, X and Y in this case, with our nominal measured deviations. And then to finish this off, we can go ahead and perform a color map, show us what the deviation is between the two in a more visualized style. Obviously we scanned this and best fitted, extracted our measurements, and we could have actually probed some of these information, as you mentioned with the kinetic probes. Can you purchase any other probes besides the 3mm and 6mm?
Yes, so there's a range from 2mm right up to 50mm if you needed it. So if you didn't want to go in the hole, we do have probes that can basically just enter into the hole. And with PolyWorks, once you've got your plane and then your pole, it can calculate the diameter as well, because obviously it is more accurate to probe these features rather than to scan them.
So Paul, besides the probes and the calibration items, what else can you purchase with the PMT?
So it comes as standard with your standard 3mm kinetic probe. So the idea of that, obviously, it's hot swappable. So because it's got its memory, you can just remove it from the arm. So the biggest advantage is you can just unclip it. When you've got your new one, you've got your arrow to the top, so it's just, and then it remembers its position. So you can do that with 3 or 6mm and also the laser scanner. The other extra you can get is a rotary table. The advantage of the rotary table is once you've scanned one side, you would have to turn the part over, then you would have to do the other side, and then you would have to do a fit in PolyWorks. The advantage of this, because it's got an encoder in it, it acts like an 8th axis. So when it rotates, basically it knows, the arm knows the position of this 8th axis. So you can scan and you can even probe. So just say we were to take a plane on this and actually move it, we could actually probe it as well. So it would know where it is relative. So yeah, we can show the 8th axis in action. Yeah.
In terms of mounting these systems, notice that's on a mag mount.
Yes.
Do you get a mount with the system? What are the mounts?
Yes, it comes with a base plate, a 3.5-inch width base plate. The optional extras would be the mag mount, the vacuum mount, or the tripod. Right. So depending on the size of the arm, the tripod's quite useful. This can also be mounted on a tripod because obviously it's got its own encoder. It always knows where it is relative to the arm as well.
Excellent. So what we'll do here is to demonstrate this, we'll do something very similar. We'll bring in the CAD model of this smaller part. We'll create some features, and again, Paul will demonstrate the scanning with the 8th axis.
Yeah.
So if I go ahead and import our CAD model for this. Again, I'll just create a handful of features again. A couple of planes, a couple of circles. Maybe in this case, I'll add in some comparison points as well, just to get some surface deviation. But when we're ready, we'll jump into the device ribbon again. We are still connecting to our PMT devices, so go ahead and jump into the scanning tool, and we'll get Paul to start scan. So yeah, Paul, if you do the honors.
Thank you. So yeah, because it's got an encoder, what we should be able to do is scan. And then obviously on most parts you would have to scan the back. With this, the idea of the 8th axis is we can just rotate it. So without having to do any alignments, we can scan the back and the front and get the full part. It's also available with probing as well. So you can actually physically probe the part as well. So it's quite good for large parts as well.
And in terms of the calibration process with the arm,
yes.
Obviously we're calibrating the probe, the scanner,
yes.
the turntable.
Yeah.
Can you give a bit more information on how?
So basically the turntable itself has a point in it. So all we do is basically put the arm in the point and do a full 360 rotation, right. And that calibrates. So it then knows where the arm is, it knows where the probe is, it knows where the scanner is, and it knows where the rotary table is relative to the arm's coordinate system.
Right. And in terms of calibrating the probe itself, it's just the typical nest that you rest into?
Yes, so that would be on the old ones. The kinetic ones come calibrated, so they should be plug and play. But if you choose the option for the older probes with no kinetic, you would use the standard calibration trivet that actually comes on a magnet.
Nice. And then in terms of calibrating the scanner, you've got the standard kind of white plate?
Yes. So what you would do, you would measure, so you would calibrate the probe, then you would measure the white plate so it knows where the plate is relative, mm-hmm. And then you would calibrate the scanner. And usually the calibration is this way, then on its side, frontwards, sidewards, and then upwards. So it's got all angles of the encoders.
Brilliant. And if customers didn't want to purchase an arm, I believe you offer the services?
Yes, so we can hire the arm, the 8th axis, the laptop and software with PolyWorks for about £300 a day. So it's a good try before you buy, and it's also a good option if you can't afford to buy the system and you need it for a week or two for backlog of work, then at least it's a nice option to hire it as well.
And those who do purchase an arm, is there a service contract or warranty?
Yes, so we can have a 1 to 5 year warranty with it. You can have a standard warranty, which means we will repair it or calibrate it in the UK, in Manchester, or you can have a premium warranty, which means we can give you a loaner while yours is away as well, so you won't be without your equipment.
Nice. Excellent. So now that we've finished scanning this, we can do what we did previously. We'll simply finish off this alignment by doing a best fit, and then we can obviously extract our features, color map, and so forth. So if I go ahead and close, once again, that's generated a polygonal mesh. So we can go ahead and now perform our best fit alignment. In this case, we'll give the automatic try again. Hopefully this will work this time. As you can see, that's now aligned, at which point I can now go ahead and extract my features. Again, similar scenario to previous, one of our circles isn't extracting very well. There's a bit of extra noise in there, but not a problem. We can always go into the properties of our holes. Again, adjust the extraction parameters to make sure they do a better job of extracting, using potentially a trimmed method and using a min fit. And then obviously with that, we can then perform an alignment. In this case, let's change it up. Let's do a best fit measurement object where we're aligning to the centers of the holes. So with those holes highlighted, I can select those and align. And then once we've done that, we can go ahead and extract our comparison points. So we get some surface deviations with our comparison points. Again, those vectors there to exaggerate the deviation there. We can adjust those if need be. I can go to view, comparison points. I can reduce that scale to maybe 10. So they're not as big. And then obviously we can finish this off by creating another color map to show us the deviation between the two across the entire scan. What we could also do is maybe increase the search distance. And that's PolyWorks using a PMT arm. You mentioned that PMT offer other products.
Yes, so we've recently got the PMT CMM in our unit, which is running the Redishow UCC controller. Right. So that will be plug and play also with PolyWorks. So we are now the official reseller for the PMT CMM as well as the ARM. Brilliant. So exclusivity to UK and Ireland. So obviously we will now be promoting that in the UK and in Ireland as well.
Excellent. Well, hopefully in the near future, we'll do a video, another collaboration with you.
Yes.
And to see the CMM in action with PolyWorks. So Paul, so how can people get in touch with you if they want more information?
So we've got our website, manchester-metrology.co.uk, and then we've got social media, LinkedIn, and obviously our YouTube channel also. You can contact the office on 0161 637 8744. Obviously, we offer this kit as an on-site demonstration as well, so if you'd like a demonstration, you can get in touch with us and you can see this kit live on your parts. And obviously, like you discussed, we can also hire the equipment out as well.
Brilliant. So thanks again for joining us. Again, don't forget to like and subscribe, and see you in the next video.